So, about the basic digital I/O. I/O standing for input output. So, Arduino pins are mostly about dedicated functions. All pins, I/O pins, can be used for generic digital input and output, meaning that the well, in some with some restrictions, of course, you should never get higher than the operating voltage on signal input. So this is a 5-volt device, meaning that the digital input cannot go above 5 volts or less than 0 volts. So no negative signals here. Output current when you're driving a load, it should not exceed 20 milliamps, which is actually quite a lot. 20 milliamps, 5 volts, it's 100 milliwatt power in principle. Analog input, there are 6 dedicated ones. So the ones which has this, I think, yeah, here, A0 to A5. And actually these can be also digital pins, but none of the other pins can be analog pins. The digital pulse width modulation output can be only on certain pins, which is actually marked with I think, yes, with a tilde character. That small character here, that's actually stands for the, okay, this can be allocated as PWM output, pulse width modulation output. So quickly calculating, yes, you can have up to 6 PWM outputs. Serial transfer, there's a receive pin, which is the pin 0, and transmit pin 1 on this lower right corner. And what else do I have here on the board? This is the power pins. You can put voltage in, meaning some different voltage, and use the onboard regulator. There's actually two different regulators. And then there are a couple of power pins. That 5 volts would be regulated from the voltage in, and 3.3 volts is also available, regulated from that one. Or actually the easiest way is just to run power from the USB connector. And then there's the external power connector also here. So plenty of different ways of getting power on the board. And then, of course, any device has a hardware reset. So it has this one. So on the top right corner, there's a reset button. When you press that one, it does booting of the system without asking anything. Okay. I/O pin. There are 3 different modes. The I/O pin can be actually defined as input pin. It can be output pin. Okay, input means that it's high resistance, high input impedance input, meaning that, okay, if you have a signal source, you can directly connect that one to the input pin without a danger of overriding this this signal output. Output pin, okay, it can give current out or sink current to a load for example, an LED. You can connect an LED like in my example there, blinking LED on port pin 13. Actually, there was a resistor for the limiting the current through current, and then the LED. Third mode is input with pull up, meaning that it works exactly like input, but there is a resistive pull up on the pin, which is connected internally, just like in here. So okay, when this pull up signal comes here, then it drives this transistor here. So it's basically a switch which turns on the resistor. And yes, this is the American way of showing the resistor. The Europeans use the box. So input with pull up. And that's pretty handy when you want to have a single switch connected to a pin. Then you can have this one, this internal input pull up to pull the pin to the initially up, and whenever you short the pin to the ground, then it gives you the low logic state. Okay, so only 3 modes, but that's enough for most of the cases. And how to set the pin on desired mode, pin mode, pin mode. But not a like in my earlier. Let's see, can I get that one? No. Like in my earlier. Okay. Let's take that back. Let's take a quick look at this here. So pin mode in here, the pin 13 was defined as an output, meaning that it can drive this LED. And we also have this resistor in series with the LED to prevent the too high current. Okay. Then there's something for you to actually bookmark for this course. The Arduino reference. So these functions are defined on Arduino. So for example, digital I/O, we have digital read, digital write, pin mode. Okay, analog read, reference, write. Okay, analog read resolution, write resolution. Okay, that kind of stuff. Advanced I/O, there's some time like delay or delay microseconds, or measuring how many milliseconds they have been running since the reset microseconds. Some mathematical functions, not too many. So some trigonometry. Okay, what else? characters. Yes, you can actually manipulate with characters. There are also some random number generators. Okay, how to set or clear a bit on a byte. Okay, interrupts, that kind of stuff. And USB actually, this Arduino can act as USB keyboard or USB mouse. Okay, so back to the business. So Arduino function reference, you will be needing that. But back to digital I/O, digital write high or low to a digital pin, any pin number, okay. And it's recommended to use the pin, to set the pin in a suitable mode prior to using digital write. Not required, but recommended. Okay, you can do your own mistakes. And thinking why it's not doesn't work. With the high value, okay, the high value corresponding pin will output 5 volts, or if you are running on 3.3 volt output, then it actually will be 3.3 volts, or then with a low value, and then the pin is tied to the ground. Okay, but not tied. Let's see. There's some electronics in between. So there's a driver electronics for when it's output. This one drives it. It's limited with it's limited with how much it can give current out and how much it can sink current through that pin within those limitations. So practically it's a Thevenin's model. Remember the last class, on the morning class, there was Thevenin's model. So any whatsoever complex circuit of resistors and voltage sources can be simplified by using single voltage source and a series resistor. Same here. It's complex. It has some voltage supplies or something that you can model as voltage supplies, and especially that one here, the driver itself. And then maximum recommended current single source is 20 milliamps per pin, but what is recommended? Well, less than that. There are a few reasons. First of all, it doesn't take more than say tens of microamps of current to maintain say good signal to noise ratio on digital. When you get say nanoamps, then you cannot much load that output anymore. So basically smaller currents are enough. So you can actually, if you have just running this one to resistor as a load, then that resistor can be high. If you need more current than that, then you need an external transistor, which is coming up later on this course. I think it's on the 3rd week. Okay, so maximum current, recommended current. It can be less, but not more than that. Or a relay, not really. Relays are based on a coil, which basically electromagnetic coil, which actually gets some serious amount of current in order to switch on. So relays are not, they are relays from the Good old days, which were not good. They were just old. Sometimes actually these device manufacturers are telling or using confusing names for the devices, like they are those electronic relays. Electronic relay usually means it's exactly the same as a transistor switch. But anyways, when you are driving anything, any peripheral, then you need to be worried about the input impedance of that circuit what you are driving. But I think we'll pass. We will be returning into that one later on. Okay. So that was the output. But how about floating? Floating input is the one which does not have any direct connection to either, or it's ohmic connection to either the ground or the power supply or any other signal source. Floating means that it's just an open wire. It's connected nowhere. So if you have this kind of situation, you have a switch. The other end is on VCC. When you switch that one to conducting state on, yes, you will get 5 volts to the pin 10. How about if it's open? It's floating. What is the state then? It's basically depends on the voltage. And if you switch that first to VCC, then it will be remaining some time at high state or higher voltage because of the internal capacitance of that circuit. So basically this kind of device would not work as a switch. So you need to have something that forces that pin to go to basically to zero state, and that will be done by adding a resistor between that pin and ground. Yes, like that. Pull down resistor. If you do it like this, that's fine. But it's one external component. If you reverse the input logic and say, okay, I want to have a switch. When I press the switch, then it forces that pin to ground, not VCC, but ground. So invert that one to ground. Then we can also use that input with pull-up mode, which means that our pull-up resistor will be actually there inside of the circuit, and we get rid of one extra external component. Okay, there's also noticed that some microcontrollers may have built-in resistor that can be enabled on software. Arduino is one of them, and there on Arduino there was the mode input pull-up mode is exactly that one, but only on pull-up, not pull-down. So there you need to have, if you run it like this, then you actually have to have an external component. So floating input pin is a no-go. You get funny results. It's high impedance. If you put any wires to that one, then you have a antenna connected to a high impedance input, which means that you get all sorts of electromagnetic interference switching it on and off. Not good. Okay, digital I/O and input. So digital read reads the value. Yes, simple as that. Just call digital read and pin number. Okay, and returns either high or low. And use the digital write. If you have a pin, input or output, use the digital. Okay, digital write. Okay. Digital, not write, but digital in suitable mode. Oh no, that was not digital write. It was the pin mode. Okay, and more information again. It seems that this must be quite important, this link what I gave you, since it's already on at least 3 or 4 different places on this one, on this slideshow. Okay, what else? Delays. 2 delays. One is for milliseconds and another delay is for microseconds, and that pauses the execution for desired amount of time. Then we also have this timekeeping, which basically gives just a number, how many milli or microseconds passed since the startup. Okay, but now these millis and micros actually are quite dangerous in sense that they can easily actually the overflow. So if you use milliseconds, or actually if you use microseconds, it's the long integer, 32-bit integer values what it gives you. I think it was something like 70 minutes or so that counter, every 70 minutes it overflows. So it starts from 0 over again. So be careful when using these, when you're counting how many seconds or how much time has been since the reset. And again, more information, Arduino functions. Yes, now we have exercise time. Exercise template is here. Let me open or copy that one also on that. Copy, not Google. Exercise time, excellent. Just in case you want to start the exercise already. That's the link to the exercise. And before that, we might actually have a short break. How about that? And make your personal copy of this one. So do not try to make any changes on that one, but go under File and click Make a Copy on your own directory, wherever you put it. I don't care. If you are using, if you want to use the Word, then basically you can take a download as Word or rich text format, that also works. So basically you can use your the favorite editor. My favorite editor is Google. But anyways, how about that short break? 5 minutes. Or do you have any questions this far? Are you still there? Okay, so no questions. That is, yeah, okay. Okay, great. So let's have a short break. Okay, and we'll continue at 14:33.